Welcome to the Lionheart Academy. This is Richard Tai. We're today on lesson 31 of our trigonometry series. So we have completed, we have talked about all the sine and cosine graphs, the sinusoidal graphs. Today we're moving on to the graphs of tangent and the rest of the reciprocal functions, if we can get to all that. But let's go ahead and start with graph of tangent. Alright, so let's just go back to look at the graph of tangent. This is a graph of tangent in this form. This is a tangent bx minus c plus d, so it's the same thing we're dealing with with sine and cosine graphs. But let's just go ahead and briefly review the patterns, the properties of tangent graphs. As you can see, the tangent graphs has only a period of pi units rather than 2 pi, and it has asymptotes, something that we don't have in sine and cosine graphs. It's discontinuous. It's not a continuous function. So the asymptotes happen when because tangent, okay, if you remember tangent, what is tangent? Well, tangent is sine divided by cosine. Okay, so every time somebody asks you what is tangent, just go ahead and they say, well, sine divided by cosine. That's what tangent is. So whenever cosine equal to 0, you have undefined points for tangent, which is called asymptote, vertical asymptote. So the vertical asymptotes are very prominent, and they are prominent features on the graph. Okay, the vertical asymptote at negative pi over 2, at pi over 2, at 3 pi over 2. So that will determine basically what our shape of the shape of our tangent function is. So to graph tangent functions, you need to know where the x-intercepts are, and you need to know where the asymptotes are. And based on that, we can graph the tangent. We can sketch a tangent function just based on those two things. So how do we determine where the asymptotes are? How do we determine where the zeros are? Well, again, A is changes the amplitude. In this case, changes the, as you can see, it changes how the steepness of the curve. Okay, it changes steepness. As I increase A, the tangent function becomes steeper and steeper. And if I reduce it, it becomes a little bit more curved. Okay, the curve become more pronounced. And if I change to negative, of course, the direction changes. Okay, instead of coming from positive, coming down from, like, if it's A is positive, the approach is from negative infinity through 0 and all the way up to positive infinity. But if A is negative, then it goes from positive infinity down to 0 and down to negative infinity. So now let's go ahead and keep A at 1. Okay, switch back to on. This is the regular tangent, and right now B is 1, so this frequency is 1. And as we have talked about before, the period was 2 pi over b. Well, why is 2 pi? Because sine and cosine, their periods are 2 pi. But for tangent, it's going to be pi over b. Okay, pi over b, because there is the natural frequency, the natural period for tangent is pi. So as you can see, we can increase the frequency a lot by increasing b. Okay, but when we increase b, it also compresses. It not only compresses the frequency, it also changes the position of the asymptote. So B, the position of asymptote changes definitely with B, but the position of asymptote also changes with C. So again, C and B works together to determine the position of the asymptote, the vertical asymptotes. And as you know, D is the vertical shift. It will change the position of the midline, and then whereby it changes the position of the the 0. Or the center, if you want to consider that, is where it intersects the midline. Right now the midline is 0, so that's the x-intercept. Now if we move the midline up to 2 or 1, then this position that used to be the x-intercept will go up 1 or 2 units. Okay, so D basically shifts the whole thing up vertically. However many shifts vertically, either up or down, depending on the sign of D. Okay, so basically ABCD works sort of the same way as what we did before as to sine cosine, but then as to actual sketching, we have to do something a little bit differently. Okay, so let me go ahead and just jot down what we have to talk about. So the period of a tangent function, let me go ahead and write out the tangent function here. Alright, so let f of x be a times tangent bx minus c plus d. Now, we're not going to use a too much because a changes the shape of the tangent function, but how do we get the shape of tangent function? We can plug in a few points besides the zeros to identify that. Now, the natural period for tangent is pi. So the period is going to be pi over b in this case, rather than 2 pi over b. And to identify the asymptotes, we're going to use this. Bx minus c is going to be equal to plus or minus pi over 2. Okay, so it's actually two equations. It's either equal to plus minus 2 or bx minus c equal to negative pi over 2. So, well, actually it's not or, it's both. So when we have these two equations, we can plug in b and c and solve for x. And then once we solve for x, we can come up with two consecutive asymptotes. Okay, so asymptotes, there are two consecutive. Okay, consecutive. When we solve for them for two consecutive asymptotes, then we know exactly how long our period would be, and we know how exactly where to graph our zeros. Because once we graph the asymptotes, the zeros, or the center point, the x-intercept in this case, well, the center point will be between them. Will be between the two, be in the middle of the asymptote. So once we graph the two vertical asymptotes, then we know right there in the middle that is where our zero is going to be. Okay, so let's go ahead and take a look at some examples and see how we can deal with this. Alright, let's start with something simple. Okay, let's start with tangent. Okay, f of x equal to tangent of let's do x divided by 2. Okay, so we don't have any a is equal to 1, excuse me, and we don't have b. Our b value is 1/2, so we know the period is going to be a lot different. The period is going to be longer now. But let's go ahead and then calculate the consecutive asymptotes. Okay, so where would the asymptotes be in this case? Well, right now it's going to be bx minus c will be equal to pi over 2. That's will be one of them, and bx minus c will be equal to negative pi over 2. Now, where do I get pi over 2 and negative pi over 2? Maybe I didn't mention that, but let's go back to the graph. You see, on the left hand side of 0, I get negative pi over 2, so that could be my first asymptote, and then we'll have 0, which is x-intercept here, and then I have pi over 2. So that's where we get the negative pi over 2 and pi over 2. So we're basically looking at this middle section, how this middle section changes for the tangent graph. So here we have b is 1/2 x. Okay, c is 0 equal to pi over 2. So you can see clearly x should be equal to pi, right? 1/2 x equal to pi over 2. So multiply both sides by 2, x equal to pi. Here 1/2 x minus 0 equal to negative pi over 2. So multiply both sides by 2 again, so x equal to negative pi. So that means my first asymptote would be at negative pi, my second asymptote would be at pi, then my next asymptote would be at pi, and the 0 would be in between them. Okay, so let me scroll up a little bit and let's go ahead and create a graph here, so we can go ahead and graph it. Let's sketch it. Alright, so I'm going to put pi here and put negative pi here, and I'll put one more, 2 pi, negative 2 pi, so that we can graph a little bit more. Alright, so I'm not going to put anything on y yet, okay, because we don't know what the values of y are until we substitute something. Okay, so for vertical asymptotes, let's do this. Let's use dashed lines. Okay, I know on the diagram you don't really see, on the actual graph you don't see it. That's why we use dashed lines, but it's important for us to use dashed lines for our own sketch so that we know exactly what's going on. And okay, so if that tells us, right, the period is actually what? 2 pi, right? Why is the period 2 pi? Because from asymptote to asymptote is 2 pi. This is 0. Okay, so the next asymptote is not going to be at 2 pi. Okay, well, actually this is probably 3 pi here. So 1 pi, 2 pi, yeah, this is probably 3 pi. Well, negative 1 pi, negative 2 pi, this is negative 3 pi there. Okay, I spaced out a little bit too much. I guess I was thinking about getting 2 pi. So this is going to be my those are my two asymptotes. So every asymptote, you can see the space between the asymptotes are 2 pi, which agree with our period. Now I didn't calculate the period here. The period is pi over b, right? So which is pi over 1 over 2, so it's 2 pi. Okay, so that agrees with what we know. Okay, so the next asymptote will be at 3 pi. Okay, and the next asymptote will also be at and I've alright, now the midline here I have now labeled it. The midline here is equal to 0, which so is y equal to 0 is the midline. And midline is very important, okay, because midline is where the center, if I would say, center of the graph should be. Now, because right now the midline is on the x-axis, okay, has not changed yet, so the point that we're looking for is the x-intercept. But sometimes, if the midline changed, then the point we're in the middle we're looking for is not going to be the x-intercept. But so go back to what we said before. The 0, the point in the middle here, that's where the graph crosses the midline, is going to be at the middle between the two asymptotes. So negative pi and pi in the middle is going to be 0. So I know those will be my points. Okay, there will be a point here. So between every two asymptotes, in the middle of two asymptotes, right, the asymptotes between the two asymptotes will have our zeros, or our midpoint where the graph intersects, or I should say intersection point. And this intersection point is very important because that's our first point. Now, then what else can we do? Okay, now we definitely need some, okay, right now the tangent function is positive, so we know our graph will come up from the negative infinity, and then somehow we go through the middle of here and come up through the intersection, and then go up to positive infinity because our tangent, our leading coefficient is positive. So what we can do is, this is pi, right? So how about let's go ahead and plug in pi over 2 and see what happens, and plug in negative pi over 2 and see what happens. Okay, so let's do it on the side here. Let's do tangent of pi over 2 over 2, or I should say f of pi over 2. So this is the tangent of pi over 4. Tangent of pi over 4, and tangent of pi over 4, if you remember from your memories, 1. Okay, otherwise you can look at your unit circle. Let's put 1. So tangent of pi over 2 is 1. Okay, what about f of negative pi over 2, which is tangent of pi over 2 over negative pi over 2 over 2? Well, that came out to be tangent of negative pi over 4, right? When you divide by a fraction, you multiply by its reciprocal. So when you divide by 2, when you divide by any number, you can multiply by its reciprocal. So when you divide by 2, you multiply by 1. This is equal to negative pi over 2 times 1/2. That's where you get negative pi over 4. And this is negative 1. So negative pi over 2 is going to go through negative 1. So now I have enough points to go ahead and draw. So I know this graph comes from negative infinity across the close to the asymptote, and then come through this and go up like that. Okay, so this is just a rough sketch. So let's go ahead and try to do it one more time. Okay, so between pi and this is actually 2 pi. Between pi and 2 pi, this is another point here, halfway through 1 pi and a half. This is 2 pi and a half. But I already see the pattern here, so I know this 1 pi and a half, it will give me a negative 1. 2 pi and a half, it will give me a positive 1. And this pattern will continue, so it will go from negative infinity, it goes up like that. Now my sketch is kind of like ugly, I'm sorry. It's not exactly how how it should be, but basically we're doing a general pattern here. Alright, so that's a rough sketch of this function tangent equal to x over 2. So it's not very difficult as long as we are able to identify the asymptotes and identify the intercepts of the midline and the graph in the middle, and then we can plug in a few points to identify 2 extra points, and we can see the pattern of the graph. Okay, let's go ahead and try another one. Alright, so let's take a look at this. So we have a equal to negative 3 for this function, y equal to negative 3 tangent 2x minus pi over 2. So b is equal to 2. Alright, and so the period we know is going to be shorter, and c is equal to pi over 2. So we know there will be phase shift. There will be shifting, the changing asymptotes. Alright, so let's go ahead and identify the asymptote. I know the period, we can always identify the period, but it will help us a little bit later, but it won't do too much. So it's pi over 2. But the most important thing is let's look for the asymptotes. Alright, the asymptotes is bx minus c equal to negative pi over 2 and bx minus c equal to positive pi over 2. Now remember, pi over 2 and negative pi over 2 where the original asymptotes are. But b and c will change that. Okay, so 2x minus pi over 2 is equal to negative pi over 2. So let's go and solve for 2x. So I add pi over 2 on both sides. If I add pi over 2, it will be 0. So x then divide both by 2x will be equal to 0. Here, 2x minus pi over 2 equal to pi over 2. So I add pi over 2 on both sides. Now pi over 2 plus pi over 2 is pi. So divide both sides by 2x will be pi over 2. So that means the two consecutive asymptotes will be at 0 and pi over 2. So that gives us a good idea of where to plot everything. So let's go ahead and do that. And that agrees with our period, right? Our period is from 0 to pi over 2. So I'm gonna go ahead and do let's see, let's go and mark 0, let's mark pi over 2 here, let's mark pi here, and let's mark negative pi over 2 there. So I try to space out evenly. Alright, okay, so let's go ahead and use a horizontal use some vertical dash lines to mark our asymptote. So our asymptote is going to be at 0, pi over 2, 0 pi over 2. So the next one will occur at pi. The previous one will occur at negative pi over 2. So, so every pi over 2 I have an asymptote. And the midline, now I don't see any d number here, so the midline again is going to be on the x-axis. I just want to mark it so we know where the midline is. Because that should be it's always good practice to make sure you mark everything, because when the midline changes, your middle point will change. Now I know with my midpoint, my intersection point, not midpoint, but intersection point between the midline and the graph will occur halfway. So in this case it's pi over 4. Okay, it'll be pi over 4, and here it's going to be 3 pi over 4. Alright, so I have this is going to be negative pi over 4 while having the section point. Now let's go ahead and plug in halfway between pi over 4 and pi over 0. So that halfway between 0 and pi over 4 is pi over 8. This is going to be 3 pi over 8. Now how do I know it's 3 pi over 8? Because if I divide this is 1 pi over 4, right? So divide pi over 4 into half is pi over 8. So this is again quarter, right? We divide 1/2 into 4 parts. So each part is 8, 1/8. So it's 1/8, 2/8, 3/8. So this is 3 pi over 8. So let's go ahead and plug in f of pi over 8 and see what happens. So it will be negative 3 times tangent, negative 3 times tangent of 2x. Okay, so it's 2 times pi over 8 minus pi over 2. Alright, so let's go ahead and work it out. So basically we're just plugging pi over 8 into the function here. So negative 3 tangent. Alright, so let's see what's happening inside. So 2 times pi over 8 is pi over 4. Pi over 4 minus pi over 2, so it's negative 3, negative pi over, okay, so it's, hold on, it's pi over 4, right, minus pi over 2. But pi over 2 is 2 pi over 4, right? So it's negative pi over 4. Alright, so it's negative 3 tangent negative pi over 4. Now what's negative pi over 4 is negative 1. So it came out to be 3. So at this point, 1, 2, 3. So it's going to be at point at 3. So that means it's going to be a very sharp. Okay, and then we have to go ahead and plug in f of 3 pi over 8. Okay. So let me go ahead and erase this. I'm running out of room here. So if you need to go back see it, you can rewind the video to go back. That's a good thing about videos. Alright, so 3 pi over 8. So we plug in, so it's negative 3 times tangent times 2 times 3 pi over 8 minus pi over 2. Okay. So it's negative 3 tangent now 2 times 3 pi over 8 is 6 pi over 8. 6 pi over 8 minus, this is 4 pi over 8, right? Pi over 2 is 4 pi over 8, so that's 2 pi over 8. 2 pi over 8 is the same as pi over 4. And when you do pi over 4, it's equal to 1, so it's negative 3 times 1 is equal to negative 3. So at 3 pi over 8, I'm going to be going down here to mark at negative 3. So this is going to be a steeper curve. Something like this. Okay, I'm sorry, I'm not very good at, but you get the idea, right? Now, why is negative? Because the coefficient is negative, so it goes from positive infinity and down towards negative like this. Alright, and then every other section will follow the same pattern here. Alright, so let me see if I can make this graph a little better. So this section is kind of weird. Something like this. Yeah, okay. Here, halfway. So it's going to be like that. Okay. Alright, so we're making a very rough sketch. Okay, tangent is not that we don't often have to make this kind of sketch, but then this is a good idea to know how to do it. Okay, because this way will allow you to have a little bit more understanding of what's going on, and understanding the shifting and different transformations of tangent graphs. Alright, so this is all we need to talk about in tangent graphs, and I think we don't have enough time to go ahead and go on to talk about other reciprocal graphs. But once we know how to graph sine, cosine, and tangent, we can graph the reciprocal graphs very simply. Okay, I think we'll go over that in our next video. So if you have any questions on tangent graphs, comments, please leave your questions and comments in the comment section below, and please subscribe and then to our video channel, and then you can recommend this to your friends and classmates if you find this helpful. Alright, and hopefully we'll see you next time in our video lesson again. Thank you.